All right, welcome. Thank you guys for being here this morning. I know that early on a Friday morning is tough, and we just appreciate you being here and being ready to participate and learn. I I hope that you walk away with something that's super helpful today. So here are our two goals. One is to select, modify, or create rich mathematical tasks. So I want you to be able to know enough about what rich math tasks are to be able to find them or make them. And then our second goal is that we will know how to facilitate them. And we're going to talk about this launch, release, return setup. There are other ways to talk about it, before, during, and after, those kinds of things. Kelly, I'm getting a message from someone. Can you let them in the Zoom? I don't think I have a waiting room, so I'm not quite sure. Maybe you're able to see that. So those are our two goals. All right. So here are our agenda. We'll do the norms first. Then I want us to experience a task. We're going to walk through what it feels like to be a student doing a rich task. And then we're going to go through what makes the rich task, how we facilitate it. And then at the end, I've chosen some frequently asked questions that as I've gone through learning how to do rich tasks or worked on with other teams implementing them, things that I feel like I've been asked a lot. And so we'll talk through some of those. These are the norms that might seem familiar to you, but I hope that we'll use, especially when we break up into small groups to practice a task together. I hope that you'll have equity of voice. So that might look like if you have a teammate who you haven't heard their math ideas, you might call them in and see if you can get them to offer what they're thinking. I do want you to advocate for your own learning. So if at any point you're like, what the heck are you talking about? Or you can't see something that I think I'm sharing, any of that, let me know. And then just making sure that we use growth mindset language, that we talk about our math ability in the same way that we would want our students to talk about their math ability. All right, so we're going to jump right in to what does it feel like to experience a rich math task, to be that student. So I want you to have your student hat on, but I also want you to, if you are noticing some of the teacher moves that I'm doing, and then we'll kind of reflect back and talk about them. Okay. So we're stepping into the launch part. As the teacher, I'm telling you that part. But basically, when we launch a task, we are setting it up. So this set up the task for us. We have this expression here, and a paint splotch has been dropped in the middle of the expression. All right. So we know some things about this expression and what the value of this expression would be, but we don't know everything. We don't know exactly what this expression would be worth. So what we're going to do is you're going to see in just a second a slide that has 5 expressions that look like this, except for that the second half, the operation and the second number are different. So what I want you to do is you're going to navigate to the slide that matches your breakout room number. So if you look like this, see how that one says team 1. If you end up in breakout room 1, you're going to navigate to that slide that says team 1. And I'm going to give you the link in just a minute. And then I want you to take a minute of silent think time. And I know that's going to be really hard for all of us, right? To not talk, but I want somebody to actually set their timer and give everybody in the room at least 1 minute of quiet think time. If then take a pulse and say, does anybody want more time? And if so, allow one extra minute. And then after 1 or 2 minutes of silent think time, then your job is going to be to take the 5 expressions that you're going to see on the screen and actually move them to be in order from least to greatest. And let's say that least will be at the top and greatest will be down at the bottom. So you are going to have to use what you know about the operations to help you figure out which one of these is going to be worth the least, which one of these is going to be worth the greatest. And I want you to not just do it. I want you to talk about how you know. What's your thinking behind, oh, I know this one's really big, or I know this one's really small, or I estimate the answer to this expression or the value of this expression would be about something. I want you to talk about it so that you're hearing each other's math, because you might be really surprised, or maybe not surprised at all, that you and your teammates are thinking about it very differently. if you have time, show your thinking, and you can, so that would be not just ordering them, but maybe like adding comments or typing right on the screen in text boxes, whatever, show how you can record how you were thinking about the order. And then if you finish early, I'd like for you to pick 2 cards that are on the screen. So maybe like your biggest one and the one right before that. Pick those 2, or any 2, and then see if you can think of a number that would definitely fall right in between there. So maybe you might be like 7,000. That's definitely a number that would fall right in between those 2 cards. Okay. Let me step back. Teacher hat. No, that was a lot of directions, but I'm also giving directions to adults. And so when the launching of the task was for students, it would probably be a little bit simpler. But I wanted to pick a task that would be a challenge for, an appropriate challenge for our group. Okay. So I'm going to ask, first of all, what questions do you have about the task and what you're going to do? I think we are ready to go into groups, and then pay attention to what group number you're joining, and that'll tell you what slide to navigate to. And then make sure you give that, once everybody's in the right place, make sure you give 1 minute of quiet think time so people can gather their thoughts. All right, let's open the rooms. All right, welcome back. Thank you I was hearing some fantastic discussions. I didn't get nearly around to as many groups as I had hoped to, which in person in the classroom would be much easier, right? But that moving between breakout rooms is tricky. So we're in the return phase. Thank you for returning back, and we're going to get back together. And I have asked two individuals to share some of their strategy. And the first one, there's going to be a little flipping back and forth. Sorry. The first team that's going to share is from team 4. I don't know who finally decided to share the idea, but that was Tammy, Alicia, and Amy, and someone else. So if you want to go ahead and tell us specifically about how did you decide that the 6,000 something divided by 92 was going to be at the top as our least?
So I have to be honest, after you left, we were trying to figure out like a number. We forgot to do that.
Okay, that's all right. That's all right. So share what you know, Alicia. How did you, and you agreed right away. How did you know to put that 6,000 divided by 92 at the top?
So I was just thinking like groupings, and I think visually like that's 92 groups, right? So you're splitting 6,000 something into 92 separate groups, and that's a whole lot of groups. So I figured out of all the other types of operations, well, it's getting smaller, and so is subtraction, but it's not, and I just didn't think it was enough. So
okay, good.
700 times, or 7 times 9. I don't know. Anyway.
So you're thinking what? Let me see if I can revoice what you were thinking. You're thinking, I've got this big pile, but I've got to split it up into 92 smaller piles, and there's going to be a pretty small amount in each one of those 92 piles. That's how you were thinking about division.
Yeah.
Fantastic. Thanks for sharing that. If we were in the classroom and we had all the time in the world, I'd hear some other ways that people estimated that divided by 92, but we don't right now. So I'm going to move ahead to one other interesting idea I had, and that was Catherine. I think, Catherine, can you tell me which room you were in?
We were on team 6.
Okay, Catherine's going to talk. I asked their team to talk about how did you specifically figure out the order of the teal and the purple? So how did you know that the purple was going to be more than the teal?
Right. So when we were comparing the teal and the purple, we decided that when you're multiplying that 6,000 number by 3, that's essentially adding it 3 times. So that's going to be more than just adding a 6,000 number 1 time. So that's why we decided that the teal box was less than the purple box.
Catherine, thank you. I don't know if you can see everybody, but you were getting lots of nodding heads, even one clap. So I think that many people, your explanation was really clear, and it sounds like a lot of people were sort of thinking the same strategy. Awesome. I wish I could have heard everybody's strategies, but I think that you've gotten the idea of what it feels like to go and do it and then maybe come back. I'm wondering if we can just have like a hand up or a nod or something. Did anybody just now when Alicia shared or Catherine shared, did you learn something new from their strategy? Like, oh, I didn't think about that. Do we have anybody who their thoughts were different? Okay, from the people I'm seeing, no, but that's okay. I bet if we had more time to share, other ideas that you hadn't thought of would come out. Okay, thanks, y'all. All right. So we have now done the return part. I would have typed in here, Alicia and Catherine, but didn't get there because I was too busy listening. All right, so we've experienced it. That is basically what doing a rich task feels like as a student. So now we're going to move into, well, what do you actually mean by a rich task? That's our next step, okay? So here are, I think, 4 of the most important qualities to a rich task. If you read in different places, you might see them called a worthwhile math task. It's the same thing. There's a little bit of different descriptions everywhere. But as I read in a bunch of places, these were the repeated descriptions. So the first thing is that students don't have a prescribed rule or method to solve the particular thing that you're giving them. If you have already taught them how to add a 2 by 2 digit number, and you give them a problem that's really a 2 by 2 plus 2 digit number, 2 digit plus 2 digit number, that's not really a rich task because you're just asking them to sort of remember or regurgitate what you've already taught them. A rich task comes when there's still some of that, like, I've got to figure it out kind of step. That's one of the things that makes it a rich task. The second thing is high cognitive demand. And I have linked here, we won't just go into super detail, but I've linked here on this for you to have some examples of how you can know whether it's low cognitive demand or high cognitive demand. So, this is that works this way. The lowest procedures without connections is a little higher. And then we want our rich tasks to be in one of these two. You're seeing my cursor, right? One of the right-hand side. So we want it to be where they're doing math. So we're exploring non-algorithmic thinking. They have to analyze. And so there's a whole lot to take in this chart, right? But if you are trying to assess, does this thing that I want them to do, is it a rich task, and does it have high cognitive demand? You can sort of look how many does it check off on this right-hand side as the goal? Okay. I love this one. A rich task needs to have multiple entry and exit points. And I think that sometimes you may have heard me say low floor, high ceiling as another way to say the exact same thing. And what that means is that if you think about your class, and all of us have a range of abilities and background knowledge, it's a rich task if everybody almost everybody has a way to attack that task. And in some cases, it would be completely concrete, right? Like they would just start by one, and whatever the thing is, like doing it concretely, all the way up to somebody who might already know an algorithm and they can attack it algorithmically. I think about this one that I did in my class a couple of years ago in 4th grade, where it had to do with area of this, like a plus shape that they were trying to figure out. And there were some kids that, had some idea about how area would work, but they'd never worked with an awkward shape. And I had some kids that had no idea. And so they literally started building the thing, like on my rug. It was humongous, like square by square by square. They had a way that would be the low floor, right? And then the high ceiling means there's a way to take it, to add a challenge for it to be harder and harder and harder, and it can be attacked in a more abstract way. And then finally, the relevant context is important. So placing it's not just a problem, but it's placing it within something. In 2nd grade, we did a rich task this year, and the relevant context was a bag of Takis. And every time the teachers actually pulled out the real Takis, they were like, they were into it. They were bought in right away. Mine that I showed you, my paint splotch thing, the context was not really a relevant context. I will go ahead and admit that to you. But the better ones, the best ones, are going to be where the context is relevant and interesting to them. I'm going to pause, and I want you to read through the Why Rich math test to yourself. All right, so I could go on and on about the why all day long, but I think that it will. Well, I want to say one piece to that is that It's super valuable, but also remember that we had an RSP vision, and this is that third quarter moving towards, thing that we want to all commit towards working to do. That was really garbled. But besides these being super valuable, this is part of our vision that we're sort of making sure everybody's on the same page. So I could talk all day about the values of it, but I wanted you to hear from one of your colleagues. So I asked Harmony to, she's been jumping in. This is her first year teaching math in the classroom. Like she taught math last year virtually, but this is her first year teaching math. She has more experience, English and all that. And she jumped in with 2 feet and has been trying Rich Task all along from the first week of school. And so I asked her, why is it valuable? Why do you do Rich Math Tasks? What's the value to you? So we're going to hear, it's just 1 minute. We're going to hear her talk about it. If for some reason the sound isn't working, give me a sign.
The reason that I do Rich Tasks in my classroom is I feel like it gives our students a meaningful experience. They're able to discover their math as opposed to just me directly telling them this is how you figure this out. And it gives them like a sense of investment. There are so many times in my classroom where when we go to start the task, they're like, oh, I can't wait to figure this out. And they're engaged and they really do want to get to the solution. And it's really cool to see them all get there in different ways as well. And then sharing at the end is just a great time of reflection in my classroom because we're seeing 3 or 4 different ways to arrive at the same place often. And so, yeah, they're just invested. They get to discover it for themselves and it's meaningful.
All right. So I also, so our next step is to look at some examples. Like you saw a Rich Math Task. We did one together that is probably appropriate for like 5th grade. That's the one that we were working on. But, I know all of you are in different grade levels. And so I want you to have an opportunity to think, what does this actually look like in my room? Because I certainly wouldn't hand them the paint blotch thing. So what I'm going to ask you to do in just a minute is to go to the VDOE site. And the VDOE has created Rich Math Tasks for our students, and many of them have actually field tested with students, and you can see student work. So what I want you to do is just click through and read some of them to see what they look like. So for example, let's say you were a 1st grade teacher. So you're just going to scroll down to look at the 1st grade section and then look for the ones that say student version of the task. So if you go to the task template that has like a ton of the teacher material too, I just want you to just focus on the task. So I would, for example, open this one up, the PDF version, read through it, kind of understand what it's doing, maybe even look at what SOL it's attached to, and then just go to the next one. Just take a look at what's there. Pre-K teachers, if you'll look at the kindergarten ones and then think about how they might be able to be adjusted for your people. So let me give you hold on 1 second. We're going to take like probably 2 minutes to look. And if you finish looking at, here we go. If we finish looking at at your grade levels, try looking at the grade level below and the grade level above also. All right,
And
so
Tracy, I have a quick question for you. So with the Building Fact Fluency Kits, how are like the contextualized practice problems or the 3-act tests different because they do have the missing components? So I'm curious, is that the same thing? Is it different if we do those daily? Like what is the...
Yeah, that's a great question. And I have planned to talk about what parts in Building Fact Fluency sort of fit into this. So thanks, Liz, for bringing that up. And I'll make sure we talk about that. Perfect. Okay, hopefully that gave you an idea of what some grade level appropriate Rich Task looks like. I'd like you to navigate to slide 26 and 27 and pretend we were in person. What would you turn and tell your neighbor at this point? It could be a question. It could be a, hey, did you see this task? This looks really cool. It could be a question. So on slide 26 or 27, you're just going to double click in any box and just put that thing that you're dying to say. Question you want to ask, whatever. Don't think too hard. All right. I'm seeing one theme I'm seeing is like Whoa, these are well done, and a couple people did not, know that they were there. So I'm glad that you are seeing that. I agree. I think that they're a fantastic resource. All right, if you're finishing up an idea, that is totally fine. Keep on going. All right, moving ahead to how we facilitate a rich math task. I hope you were kind of gathering that from my modeling example, but it starts with the launch, and the launch is, well, actually it starts with choosing the task, right? But after you've chosen the task yourself and anticipated what student thinking is, or how students are going to solve it, then in the classroom, the first thing is to launch. I didn't do a ton of activating prior knowledge, but there might be some instances where you would want to do that, like, hey, remember this tool and how we've used it. You don't want to like pre-teach too much, but there might be some activating of prior knowledge that needs to happen. Then clearly you want to explain the task, and you want to set classroom expectations of how that's going to work. And one of the most important parts of that is to let them know what tools are available and where they can get them and how they can get them. I facilitated a task in a class one time when a teacher wasn't there, and I was like, okay, go. And they were like, where are our tools? Can we use the tools? So clearly tools had been an important part of the task the tasks in their classroom. So you would want to pick out the tools that kids can use ahead of time and make sure you have a plan of how they're going to get them. Then the next part, which for some of us is the hardest part, some of us is the favorite part, is the letting go, right? And there's that scary moment of like, they don't know what to do and I need to rescue them all, right? Well, we don't. We need to let them go and have that time to do it. I always like to start with quiet thinking time because I need it as a learner. I need some quiet thinking time before I'm ready to jump in and talk about it. So I like to have that quiet thinking time and then group them together, because so much more rich conversations are going to happen when they are talking to each other about the math. And your job is not to do it for them. Your job is to notice what's happening. So I was trying really hard when I went into the 2 rooms, I went in to just listen and then listen for that mathematical thinking. I, recorded it, what I was hearing down here, and provide support when you need to. And a lot of times that support will come through questions, not through telling. It'll come through questions that you've prepared ahead of time. And then there might be opportunities to make extensions. Some kids are going to solve it right away. And your first step is, hey, can you record your thinking on that? And then your next step is to give them an extension. That's where my pick a number that falls between the 2 cards. That was my extension. I went ahead and gave it to you so that, because I couldn't get to all the groups. Okay. And then the return part is where, when we came back together and we shared the ideas, it's not who wants to share an idea, who wants to share how they did it. It's very focused, like choosing who's going to share in order for you to tell us a mathematical story. So I specifically ahead of time planned, I wanted to hear how that division problem, how did people grapple with a 6,000 divided by 90? Yikes, that's really hard to estimate. I wanted to hear that. And then I wanted to hear how we knew that the addition was going to be less than the multiplication. So I chose those people to bring those out. And then my job as the teacher is to try to connect that. I kind of ran through that section really quickly. But I would connect other ways that people had done those particular steps. So that's the return phase. Another way to say it is like the before, the during, and the after, right? Okay, we're running through 4 minutes. Let's go through some of the frequently asked questions. They won't all be finished, but that's okay. The first thing is where to find them. Okay, well, the best place to look is that VDOE collection. I saw, why aren't there some for all of the standards and why aren't there student samples for all of them? It's just because real teachers have created them and there's only so much time. So it's in the VDOE's goal to keep creating them. But it's just, they started this about 2 or 3 years ago, and it's just been a process. Liz asked a great question about building fact fluency. So for those of you that, well, actually, both the addition and the multiplication have 3-act tasks. The multiplication kits have way more. That is definitely an example of a rich task. I also think that the anchor problems, the one where you give them the like it's one of the first things in the step that can be a rich task also. And those of us who've done them together, we've anticipated them much like a rich task. Liz, did I answer your question that the 3-act task and the anchor problems are rich tasks? Okay. We just got this year, we got these books that are super cool that are from Corwin, and they're called Classroom Ready Rich Math Tasks. They're like in here for you to check out. And they are just full of tasks ready to go. And the Pank, so here's the 2nd and 3rd grade. They're very pretty. Here's the 4th and 5th. And the paint blotch one came out of here. So these books are a great place to start and have tons of different rich tasks. I have created a spreadsheet of 3-act tasks that helps you, makes it way easier than just searching online, and then 2 more websites here. I know the 3rd grade did a lot of the U-cubed ones at the beginning of the year. And then we can also work together to create our own or edit something. What I'm going to do, instead of rushing through the rest, I'm going to finish up the rest of these frequently asked questions as needed in PLC, because I don't want to just run through it. So